You know that feeling your Spark job has been running for hours and then it just fails, all because of some tiny error you could have caught beforehand? Well, today we're diving into the solution, the really powerful, type-safe world of the Spark Dataset API, specifically for Scala. Okay, so here's our game plan. We're going to start with the basics. What exactly is a data set? Then we'll get our hands dirty shaping and combining data. But you'll want to stick around for the end, because that's where we get into the real juicy stuff, the performance secrets that'll make your Spark jobs fly. I mean, seriously, if you've ever had a massive data pipeline fail hours in just because of a simple type mismatch, you know exactly how frustrating that is. It's a huge waste of time and resources. So Spark has this amazing solution that catches those kinds of errors before they can wreak havoc, and it's called the dataset. This thing really is a game changer. So what makes a dataset so special? The crucial thing to get here is that it's not just a collection of rows, right? It's a collection of actual objects with types you define. This gives you the safety of the old school RDDs, but with all the awesome performance benefits of modern DataFrames. It's truly the best of both worlds. Now, you might be wondering, how does Spark pull this off? Well, the magic behind the curtain is something called an encoder. You can think of it as this incredibly smart translator. It takes your custom Scala objects and converts them into Spark's super efficient internal format, all automatically. You get the safety without sacrificing speed. All right, that's enough theory. Let's see how this actually works in practice. We're going to dive into some real movie data and see how we can shape it using these powerful type-safe transformations. We're going to focus on two really fundamental operations here. First up is map. This is your classic one-to-one change. Think of it like an assembly line. One item goes in, gets a quick modification, one item comes out. Then you've got flatMap. This one's different. It's a one-to-many transformation. One record goes in and it can produce 0, 1, or even a whole bunch of new records on the other side. And this right here is a perfect example of flatMap in action. Look at this. We take a single movie record that has a string of genres, all separated by that pipe character. And with one line of code, we transform it into multiple separate records, one for each individual genre. Super powerful stuff. Okay, shaping a single data set is great and all, but the real power in big data comes from combining different data sets. So let's take a look at how we can do that, and more importantly, how we can do it safely. And this is a really, really important distinction. You have two main options, join and joinWith. A standard join, well, it works, but it throws away all your type information and gives you back a generic data frame. All that safety you had is just gone. But joinWith, that's the one you want. It keeps everything perfectly typed, returning a data set of tuples, which keeps your whole pipeline safe and sound. And this just illustrates the power of joinWith so perfectly. You can chain these joins together one after another, and what you get is this beautifully typed, nested structure that your code completely understands. You can access fields like under1.under1.rating with total confidence because the compiler will check it for you. No more runtime surprises. Okay, now for what might be the most critical part of this whole explainer. We're talking about grouping data. This is something we do all the time, but if you do it the wrong way, you can absolutely destroy your job's performance. So, listen up. The source material gives a really stark warning about this one common operation, groupByKey, and trust me, it's for a very, very good reason. So here's the problem. groupByKey has to pull all the data for a single key onto one single machine before it can do any aggregation. Imagine you have terabytes of data for one key. It all has to get crammed into one executor's memory. This causes a massive data shuffle across the network, and it's a recipe for out-of-memory errors and incredibly slow jobs. But what if there's a smarter way? Of course there is. Let's look at how Spark's engine can optimize these aggregations when you use the right tools for the job. So, when we use the much more efficient DataFrame groupBy instead, Spark follows this incredibly intelligent plan. First, it does a partial aggregate on each machine locally. Then it shuffles only those small, partially aggregated results across the network. And finally, it combines those partial results into the final answer. The key is that the big, expensive shuffle happens after the data has already been shrunk down. And just look at the result. This number from the execution plan says it all. By aggregating first, the total amount of data that actually needed to be shuffled across the network was tiny, just under 37 kilobytes. That is a massive difference. Now, 37 kilobytes might not sound like a huge number on its own, but why is this such a big deal? Understanding this really reveals the genius behind Spark's performance. It all comes down to this amazing feature called Adaptive Query Execution, or AQE. Spark is constantly watching your job as it runs. It sees that tiny shuffle size and says, hey, I don't need 200 tasks for this little bit of data. And it will dynamically change the plan on the fly, reducing the number of tasks to avoid unnecessary overhead. It's basically Spark optimizing itself, which saves a massive amount of time. So to wrap this all up, what are the key things to remember? First, always use datasets for that compile time type safety. It'll save you from so many runtime headaches. Second, when you're combining data, make sure you're using joinWith to keep that type information. And finally, and this is the big one, stay away from groupByKey, use the DataFrame groupBy instead to let Spark work its magic with pre-aggregation and optimization. So now you don't just know how to use the API, you know the why behind it. This is the kind of knowledge that helps you build not just code that works, but code that is robust, efficient, and truly scalable. So, what amazing data pipelines are you going to build? Thanks for watching.